Okay, great question. So number 24, page 194, it has y equals 1 over x squared minus 1. What a great function. All right. So,
Are we supposed to know what that's supposed to look like?
not in Calc 1.
Okay.
This is going to come out in Calc 2. It's quite beautiful.
Yes.
All right, but so next year you'll like it. All right. Yeah, it really is. All right. So first of all, we just take the derivative, set it equal to 0. So there's a certain amount of brute force calculation we can just do automatically before we have to start thinking. So dy dx. The derivative of this by the quotient rule is going to be negative 2x over x squared minus 1 squared. Is that correct? Is that the derivative? Someone check me?
Yeah.
Okay. Set it equal to 0. So 0 equals negative 2x over this stuff. Cross multiply, the denominator goes away. So 0 equals negative 2x, 0 equals x. Okay, so I know that is a critical point. Alright, I know it's a critical point. So let's decide what kind of point is it. When I'm to the left of 0, whenever I plug in, first of all, I'm squaring my denominator, so my denominator is always positive. So if I plug a negative number up here, the numerator is positive, so this is positive. If I plug in a positive number, the numerator is negative, so the whole fraction is negative. See how easy that was? That's why I said this way is usually easier. I don't have to find the second derivative, because the second derivative of this is a lot more cumbersome than the first derivative. All right, gross, I said. I agree. I concur. All right, and so I don't have to plug in 0 to the second derivative. I can just say, hey, positive, negative. If a function's increasing and then decreasing, guess what? That's a maximum. Okay. It's maximum. That's what it is. Okay? When in doubt, you can say local. You know? Because even the absolute ones are local in their domain. Okay, so that's a maximum. And so I would say, okay, that's a local maximum, but then I guess we would have to then know what that function looks like to say. But I know that, what do we know? This function exists for all x values that are positive. Right?
Greater than 1.
Oh yeah, x value, yeah, to the outside of 1. No wait, it exists for all x values. Oh, except for x equals 1 or negative 1. Okay, so let's say we want to graph it. So we go negative 1, 1. We'll have our vertical asymptotes. And we know that when x is 0, y is negative 1. And then we just said that's a maximum, so it looks like this. Now, using Coach Bruce laws, as x goes to infinity, what's my y value going to be? As x goes to infinity, my fraction goes to 0. So that's going to be my graph. How do I know that? Because it's a vertical asymptote. So as I get closer, but we can check.
Why not down?
Good question. Why not down? All right? Maybe it does go down, actually. I don't know. I didn't really think about it. If I get a number is bigger than 1, right? So the number is bigger than 1 to the right, then this denominator will be positive. So I know my fraction will be positive, so it's going to go to positive infinity. And then negative 1, it'll still be, as I get close to like negative 1.1, it becomes positive, so it's still positive, so I know it goes to positive infinity. So I just like plug in points that are close to 1.
Wouldn't it be a really small number?
Yeah, and you're dividing by a really small number, which gives you a really big number. So when the denominator is really small, your fraction is really big.
I thought your denominator would be really big.
For example,
You had like,
when x equals 1.1, we've got y equals 1 over that square, which is 1.21 minus 1. which is 1 over 21 over 100. So y equals 100 over 21, which is like 5, right? And if I plug in numbers that are even closer, like 1.00001, this gets a lot bigger.
So it goes down really quickly. Like it's
Yeah, my graph is maybe not to scale. But yeah, it creeps, and then it just shoots up.
yeah.
Yeah, but the general picture is still right. I just recognize the pattern, like, that's why it went up. But it's a good question. So that's what my graph looks like. So absolute wise, it goes to infinity. But in terms of your critical points, there's only one, and that's a maximum. But as you can see, that maximum is not even very good, because to the right of 1 and to the left of -1, you're even higher. You can go, up here. So yeah, local maximum for sure. All right, good.